Just off the coast of Brazil lies an island so dangerous that almost nobody is allowed to visit. Hidden among its rocky terrain and dense vegetation lives one of the highest concentrations of venomous snakes anywhere on the planet. This is Snake Island, a place where nature evolved in extraordinary and terrifying ways. On official navigational charts, this rugged outpost in the southern Atlantic is recorded as Ilha da Queimada Grande. It sits approximately 33 kilometers off the southeastern coast of Brazil, directly parallel to the state of São Paulo. To the public, however, it is known worldwide by a far more ominous title, Snake Island. This name alone carries a fearsome reputation, turning a remote, uninhabited rock into one of the most infamous places on Earth. For over a century, harrowing tales of lost sailors, tragic encounters, and a forest teeming with lethal predators have dominated its lore. The sheer scale of its terrifying reputation raises a central question. How did such a small, isolated landmass become the subject of such intense global dread? While popular folklore paints a picture of an inescapable death trap, the actual truth of this mysterious sanctuary is far more complex than the terrifying legends suggest. To understand the true nature of Queimada Grande, modern researchers must separate local folklore from scientific reality. This isolated outpost spans just 43 hectares of steep, rugged terrain. Its cliffs rise sharply from the Atlantic, presenting a formidable barrier of dark, weathered basalt that reaches a peak elevation of 206 meters above sea level. The surface is a complex physical mosaic, where dense, humid, lowland rainforest covers roughly 60% of the land. The remaining territory consists of windswept grasslands, deep ravines, and barren rocky outcrops that endure constant exposure to intense tropical sun and heavy ocean winds. This distinctive physical layout is the product of a massive geological shift. Approximately 11,000 years ago, near the end of the last ice age, the planet underwent a dramatic warming phase. As massive continental glaciers melted, global sea levels rose rapidly across the broad São Paulo continental shelf. What was once a high, rocky hill on a continuous mainland peninsula slowly transformed into an isolated peak as the ocean advanced. The rising waters eventually flooded the low-lying valley that connected this ridge to the South American continent. This inundation submerged the land bridge and established a permanent 33-kilometer marine barrier separating the landmass from the Brazilian coast. This physical isolation turned a formerly connected habitat into a strictly closed ecosystem. No longer able to exchange genetic material with mainland populations, the species stranded on this tiny rock were left to adapt to a highly restricted environment. Here, the weather dictates the daily rhythm, with relative humidity averaging 74% and temperatures hovering around 23 degrees Celsius. The island's unusual biology begins not with a biological anomaly, but with this precise geological separation. Locked within this isolated ecosystem is the island's most famous resident, the golden lancehead. Known scientifically as Bothrops insularis, this highly venomous pit viper exists nowhere else on Earth. It is a biological prisoner of the rising seas, completely confined to these 43 hectares of land. To biologists, this snake represents an extraordinary evolutionary case study. Its closest relatives, the Bothrops jararaca complex, still thrive on the Brazilian mainland, just 33 kilometers away. Yet, thousands of years of absolute isolation have set the golden lancehead on a completely different path. Its physical features and behavior have drifted from its continental ancestors, creating a species defined by extreme specialization. While sensational stories focus purely on its lethal threat, scientists view the golden lancehead as a critically endangered treasure. Its survival relies entirely on the preservation of this fragile island habitat. The snake's fearsome reputation is not a matter of malicious legend, but a direct consequence of physical adaptations required to survive in a closed world. This serpent is the living heart of Queimada grande, a species whose very existence is bound to the rock it dominates. On this isolated rock, survival demanded a radical shift in diet. Unlike their mainland relatives that hunt rodents and amphibians on the forest floor, the stranded vipers faced an environment completely devoid of terrestrial mammals. To survive, they looked upward. Research led by Otavio Marques and scientists at the Butantan Institute reveals that the golden lancehead became an avian specialist, feeding almost exclusively on birds. Diet analysis shows they target two specific species, the resident house wren, Troglodytes musculus, and the migratory southern Elenia, Elenia chilensis. This dietary shift transformed how the snakes hunt. They abandon ground-level ambushes to become skilled climbers, spending much of their lives in the forest canopy. To intercept quick-moving, flight-ready prey, the vipers evolved a specialized behavioral mechanism known as tail luring. By rhythmically twitching their light-colored tail tips, they mimic insects to draw curious insect-eating birds within striking distance. But physical strategy alone was not enough. A mainland snake can strike a rodent and track its scent trail as it slowly dies on the ground. On a sheer ocean cliff, a bitten bird will fly away and perish over the sea, lost forever to the predator. Natural selection solved this problem by rapidly accelerating the speed of the snake's venom. Biochemical assays show the venom contains a highly specialized cocktail of toxins designed for instant immobilization. Specifically, researchers identified an extraordinary abundance of PI-class metalloproteinases, which disrupt vascular integrity and cause rapid hemorrhaging, accounting for over 40% of the venom's total protein mass. Alongside these, the snakes possess a highly upregulated enzyme variant called lancehead PLA2-beta, which delivers a fast-acting neurotoxic punch that paralyzes avian prey in seconds. Recent genomic sequencing by the Butantan Institute confirms that these biochemical changes are written into the snake's DNA. Although the isolated population suffers from low genetic diversity and historic bottlenecks, extreme selective pressure has forced rapid evolutionary adaptation. Comparative genomic studies reveal a 1.8-fold increase in the copy number of the genes responsible for producing those destructive PI metalloproteinases. This genetic expansion, paired with recent selective sweeps around key toxin genes, shows evolution operating under absolute constraint, rewriting a species' entire predatory toolkit to ensure survival on a tiny, closed island. Sensational accounts claim Ilha de Queimada Grande is packed with one venomous snake for every square meter. In reality, field surveys reveal a patchier distribution. Researchers estimate the entire island holds between 2,000 and 4,000 golden lanceheads, averaging roughly one snake per 120 square meters. Equally persistent is the legend of a lighthouse keeper and his family massacred by vipers. Brazilian Navy archives contain no record of such an event, documenting only routine maintenance and orderly evacuations before automation. Even the snake's venom has been exaggerated. While it causes hemorrhage and tissue damage, it does not melt flesh or cause instant death. Every documented bite on researchers has been successfully treated with standard antivenom, leaving the true human death toll at 0. The true shield protecting this island is not fear of its snakes, but federal law. Under Federal Decree number 23,748 of 1996, the Brazilian government designated the island an ecological station, completely prohibiting public access. Today, the territory operates as a strictly regulated open-air laboratory. Only 5 to 7 scientific research permits are issued each year, managed through the Chico Mendes Institute for Biodiversity Conservation, known as ICM Bio, with logistical support and security provided by the Brazilian Navy. Scientists from the Butantan Institute study this habitat under tight restrictions. Because the golden lanceheads are isolated, they suffer from a small effective population size, low heterozygosity, and constant bottleneck risks. This vulnerability turns the island from an infamous spectacle into a fragile evolutionary archive, where every controlled study helps protect a threatened genetic lineage. Today, Ilha da Queimada Grande stands as a fierce testament to natural selection. In a world dominated by humanity, this forbidden sanctuary reminds us that Earth's most extraordinary evolutionary marvels can only endure where we dare not tread. Subscribe for more deep dives into our planet's mysteries.